Okay. Well, we can start with our quiz then.
Okay. Yes. Oh, look at all those.
It's a lot. Yeah.
Oh, that's 2/3 of a test.
Yeah.
Yeah. Okay.
Okay.
Ready to go?
Yeah.
Okay. I'll read the first question. Question number 3. Which hypothesis involves equality? The null hypothesis, the alternative hypothesis, or the true hypothesis?
Isn't that the null?
I think it's the null as well.
Okay.
Want me to read number 4?
Yep.
Ready?
Mm-hmm.
Okay, number 4. Information they want you to have. The p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer the next question. Remember that the p-value is the probability of obtaining a sample at least as extreme as the one that was actually observed. When computing the p-value, which hypothesis do you assume to be true? Isn't that the null hypothesis?
I
I
agree.
agree with that.
Mm-hmm.
They really want us to remember what p-value is.
I think so. Well, yeah, they did say it was one of the most important things in this
Yeah.
lesson.
For sure.
Okay. We ready for 5?
Yep.
Suppose the null hypothesis is 10. Which of the following represents the alternative hypothesis for a two-tailed test? Oh. Okay. Mu equals 10 is what we have to start with.
But they want to know the represents the alternative. So wouldn't that be the third one?
I would think so, because that one can either be less or more, right? So two-tailed.
Mm-hmm.
Yeah.
Yeah, I agree.
Which one did you guys choose?
The third one with a equal with a slash going through it.
Okay, cool. Agreed.
Cool. Number 6?
Mm-hmm.
Okay, which of the following represents the alternative hypothesis for a left-tailed test? And there they are.
Left-tailed would be the less than, right? I mean, the less
Yeah.
I
than.
believe so.
Yep.
Yep, I agree.
I checked in the book in case you guys didn't. It's right.
Thanks. Thank you.
Thank you.
Okay, and a right-tailed test. And that would be
Go the other
greater
way.
than.
Yep. Great one.
So there's never really an instance where you would have the last choice, is there, for the alternative?
I don't think
No.
so. I think that's just the null again.
Okay, so it'd always be the less than, greater than, or different. Okay.
Yeah. Question number 8. So you remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance, or alpha. So which relationship would result in failing to reject the null hypothesis? Failing to reject. Okay, so that means the null hypothesis is all right. Okay, so the p-value is greater than alpha. The p-value is less than alpha. The p-value is greater than z. The p-value is less than z. So if we're failing to reject it, then wouldn't that be the first one because it's not below that significance level?
Hmm. I think so.
So you're saying p-value is greater than alpha?
Yeah, because alpha is that
Okay.
significance value that's like 0.05 or whatever came from the homework.
Yeah.
And if
They're
it's not,
saying that there's enough significant evidence that the null hypothesis could be true. So
yeah.
I think so.
Okay.
Okay, question 9.
Mhm.
Which relationship would result in rejecting the null hypothesis? So it wouldn't be either of the z values, it would be the alpha, right?
Yeah.
So it's between the first two. So then it should be the less than.
I agree with that.
Hmm.
Okay.
Is everybody ready to move on to the next one?
Uh-huh.
Yeah.
Okay. I will read it. So an insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim was $1,500. They are concerned that the true mean is actually higher than this. Use this information for the next 2 questions. Which of the following would be the appropriate alternative hypothesis? Either the average claim amount is equal to $1,500, the average claim amount is not equal to $1,500, the average claim amount is greater than $1,500, or the average claim amount is less than $1,500.
Think greater than?
Greater than, yeah.
I agree.
Okay. Are we ready for 11?
Yes.
Okay. Which of the following would be the appropriate null hypothesis? The average claim amount is equal to $1,500. The average claim amount is not equal to $1,500. Greater than $1,500 or less than $1,500.
So the null is the status quo, so wouldn't that be the first one?
I
Yeah.
agree. Equal to.
Okay.
Yeah, CJ?
Yeah. I think so.
Okay.
Okay, I'll read number 12, yeah?
Yep.
Okay, information. The insurance company randomly selects a sample of 40 claims and calculates the sample mean is at $1,650. Use this information to answer the next 3 questions. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? Well, since it's greater than 30, wouldn't it be the first one? It's a good assumption since the sample size is normal? Oh, or is it's a good assumption since the population is normal?
I think it's the first one because it doesn't say anything about the
Normal distribution?
about the population or parent distribution being normal. So
Yeah, we just have a sample of 40. I think you're right, Deb. First one. Okay. You ready for 13?
CJ, how about you?
Yeah. Yep.
Okay, 13. What theorem or law justifies your answer to the previous question? Law of large numbers, central limit theorem, law of total probability.
Probability is not a thing.
No, I'm always mixing this one up.
Law of large numbers. The larger the sample, the more it represents the true population mean. The central limit theorem is with the larger sample size, sample mean will follow a normal distribution.
It's the central limit theorem.
What?
Yeah, central limit theorem.
Uh-huh.
We good on that one?
Yeah.
Okay, 14. Which of the following is the test statistic as defined in this lesson?
That'd be Z?
Yep, easy score.
Okay.
Z? Okay.
Anybody have any questions on that, or are we all good?
I'm good.
I'm good.
Okay. Question number 15. The historical mean of sales receipts at a grocery store is $150 with standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis, test with the hypothesis. She will use a level of significance of alpha equals 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes XAT, or whatever that means, to be $144. What is the z-score associated with this test? Does anybody have an answer?
Do you compute these any different with like a left-tailed versus a right-tailed?
It's a left-tailed for less. No, yeah.
Yeah.
Yeah, I think it just naturally goes, because if it's left-tailed or if it's going to be less than, then I think generally the z-score will be negative, on the left side of the mean. But if it's supposed to be greater than, it will probably just be positive z-score, so I think it'll just happen.
Did you get an answer, Sarah?
I did. I got negative 0.9. It says to round to 3 decimal places, so I put negative 0.900.
Okay.
0.9?
Yeah, negative 0.9.
I don't know why I thought you said negative 0.09. I was like, what?
Oh, no.
Okay. Yeah, 0.9. Negative.
Where do you put in the alpha in the formula?
You actually don't use the alpha. You're just comparing your p value that you're going to get after the z-score to the alpha later on.
Oh, that
Yeah.
makes sense.
So, yeah.
Standard deviation of 40. Okay.
Debbie, did you get an answer?
Yeah, I got it and then I erased it. It was a negative 0.9 something. I think it was a bunch of zeros. Darn it.
Well, it sounds similar to what we got.
Yeah.
Negative 0.9.
Oh, okay.
Yeah.
Okay.
DJ, were you able to figure that out?
Yep, I got it.
Cool.
Maybe.
We're just using that, the really big z-score equation with, like, at the bottom of it, you have the standard deviation divided by the square root of your sample size.
Yeah.
So it's just that really big z-score that we're finding.
Oh, so there's 36. That's where my calculation messed up. Okay. Alright. So, I know I could figure it out, but... Whoa, you got negative 0.9?
Yep.
Okay. Did you get anything after the 9?
I didn't. Just zeros.
Zero.
Okay.
Okay, so now I need that normal probability applet for the next one. Scrolling back. So the probability is the p-score, right?
The probability is what?
What? Okay, did I say something really dumb?
No, sorry, I just didn't hear you.
Oh, so the next question asks for the probability or the p-value. So that would be using the applet, correct?
Uh-huh.
So when I plug in negative 0.9, it comes up with 0.1841. Is that what you guys got for 16?
Yep.
Looks right.
Wait, I'm confused how we got that.
So you take your z-score and you plug it in for a left tail on the probability applet.
And you got what?
0.1841.
Oh, okay. That makes sense.
Good. Are we all good to move on to 17?
Yep.
Okay. What inference would you make about the null hypothesis for this problem? Either we reject the null or we fail to reject the null.
Well, didn't it say the 0.5 was the alpha?
Yeah. Or 0.05.
So this would be
So-
more than the...
So we fail to reject it, right?
Yeah.
Cool.
Yep, that's what I think too. Fail to reject.
I thought we would reject it.
Yeah.
So, greater than... So I wrote down this one thing that said if it's a large p-value, you fail to reject it, but if it's a small p-value, you reject it. But this one's a larger p-value.
Yeah, so if p is greater than alpha, then you fail to reject. And if p is less than alpha, you reject.
Well, that's a better way to say it. Okay.
Okay.
So the guy that does the homework, the preparation video to give you the answers, he referred to the alpha as the little Jesus fish.
Kinda.
That was funny.
I see that. I actually took this class in high school, my senior year, well, similar statistics class, and I think they actually referred to it that same way, like how to draw it was the little Jesus fish.
Okay. Ready for 18?
Ready?
Question 18, what is your conclusion for this problem? First, we have insufficient evidence that the true population mean is 150. Second choice, we have sufficient evidence that the true population mean is 150. Third, we have insufficient evidence that the true population mean is less than 150. Or last, we have sufficient evidence that the true population mean is less than 150. Well, if we're failing to reject,
Isn't it the third one?
Yeah. I think that too, because there's insufficient evidence, well, like Debbie said, to reject it. But yeah, the hypothesis test was to see if it was less than 150, so we have insufficient evidence that it's less than 150.
okay.
I hope.
At
Let's go for it.
least this one we get a second try.
Yeah, seriously.
Alright. Question 19. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true?
Type 1 is rejecting the truth. I wrote that in my notes.
I agree.
That's easy to remember. Cool, I'll agree with that.
Okay. That's what the book says, so I agree too.
Cool. Alright, question 20. A researcher decided that instead of using a level significance of alpha equals 0.05, he will use alpha equals 0.01. Which of the following will be true? The probability of a type 1 error will increase. The probability of a type 2 error will increase. The probability that the null hypothesis is true will decrease. Or his experiment will be more scientifically valid.
Isn't it the first one?
I thought it was type 2 would increase.
It's my notebook around you, Zach.
Look it up.
What's a type 2 error again?
If the null hypothesis is false when we say it's true.
Yeah, I would say that a type 1 error would increase because your p-value, how do I even explain this? I was looking at my notes. Because you're more likely to reject something even if it was like 0.03, like that would still be sufficient evidence to prove that something is false, but you're saying what? What am I
Well,
saying?
a type 1 error is failing to reject the null hypothesis, and we fail to reject the null hypothesis when p is greater than alpha. And so if alpha is smaller, it's really likely, or it's more likely, that we get a p-value that's greater than that smaller number. And so that makes it seem like the first one's right to me.
Yes, that is what I was trying to say. Thank you.
Hopefully that made sense. Makes sense in my head.
What's throwing it off for me is I remember reading in the textbook or whatever, it says if the alpha value, which is the probability of committing a type 1 error, is very small, the probability of committing a type 2 error will be large. Conversely, if alpha is allowed to be very large, then the probability of committing a type 2 error will be very small. That's basically it. So
Yeah,
that's what's throwing me off.
that's true.
So how to interpret that. So my understanding was if we decrease alpha, then type 2 will go up. But maybe I didn't understand it right. I don't know.
Yeah, I'm reading the same thing that you are. Like what CJ said made perfect sense in my brain. That's what I was thinking, but now I'm reading what you were reading, Amy.
See, I thought he made sense too, but I remember reading that, so now I'm like, well, I don't know. I don't know.
That's really confusing.
I mean, like you said, it says right there, if the alpha value is very small, the probability of committing a type 2 error will be large.
Mhm.
I don't know. I mean, if we post on the discussion board, I would say to go with the book right now, even though that doesn't make sense to me either. But if we post it on the discussion board when we post all of our names that we had trouble with this problem, then she'll probably fix it for us, like explain it further.
Yeah.
Okay, we can do that. I mean, yeah, I'd rather put my money on the book.
Just doesn't make sense.
Yeah, it doesn't. Oh.
So we're going with the probability of a type 2 error will increase?
Yeah.
Yeah.
Okay, last one.
Yep.
Mhm.
Question 21, if alpha is 0.05, compute the probability of committing a type 1 error.
Isn't that the same thing? Isn't alpha the probability of committing a type 1 error?
That's what I thought.
Mhm.
I don't know.
I don't know how we would calculate anything different.
No, I don't know either. I just submitted my quiz, and yeah.
Right on.
How'd it go?
We got 100.
Oh,
Mhm.
really?
Yeah.
Wow,
So, point.
doubt, CJ.
No, yeah, I don't know. I doubted maybe one or two. Mostly number 20, though.
Me too.
Yeah,
I
that
just,
one's weird.
maybe I understand type 1 error incorrectly then.
If you do, then I do, because I didn't get that either.
Okay, yeah, I understood type 1 error wrong. So type 1 error, I thought it was failing to reject the null hypothesis, but it's actually when you reject the null hypothesis when it's actually true. So that's a type 1 error. So it's actually the inverse of that, where alpha, like if the p-value is less than alpha and alpha is smaller, then it's really hard to get a p-value smaller than that tiny alpha value.
True.
So it's inverse of what we thought it was.
That makes sense. Like what Debbie, I remembered what you said earlier, Debbie. Type 1 is when you reject the truth. And so I guess if there was like a 0.03 or 0.04 and you rejected it because your alpha was super low, then you would still be rejecting the truth. Oh man, I think I just mixed it up again.
Very.
No, you said it right. That sounded right.
Yeah, but that's a type 1 error that would be increasing, not type 2.
It's very confusing.
You know what?
Just write it down and then refer to your notes.
Yeah, seriously. Well,
Good
has
job.
everybody submitted it?
Mhm.
Yep.
Yep.
All right.
Alright. Well, I will post this, and I don't think we need to ask that question anymore because we figured it out. So, cool.
All right. Well, all of you have a good weekend.
Yeah,
You
you
too.
too.
See you all on Tuesday.
Yep, we'll see ya.
Hey,
Oh,
sounds
who's gonna
good.
do it on Tuesday?
I'd like to try, but I keep screwing it up so bad.
I think that you should keep trying because you learn more every time about it.
So how about next time if I wait till 9:30 and then go on the one that says event
Okay.
and just invite you at the last minute?
Mm-hmm.
Sounds like a good plan.
Okay, that's my plan for Tuesday then.
All right.
Sounds good.
See you all then.
All right.
Okay, see you guys.
Bye-bye.